All right, let's get into it. The last section of chapter 3. I know you're excited. I know. We are going to be talking about inequalities here. And then we're going to use those inequalities to make predictions. So I wanted to remind you just real quick of what the inequalities are. So when math teachers talk about equations, they're talking about statements, mathematical statements that have equal signs in them, right? So let me flip back here. X plus y equals 6, right there. That's an equation. It has an equal sign. Okay. And by the way, it's an equation with two variables, right? Because it's got x and y. Now, when we're in this section here, we're going to be talking about inequalities. So they're not equations, and they're going to have one variable. All right. So let me remind you the inequalities. There's less than, right, which is a plain little, I don't know, Pac-Man kind of thing. It's like the Pac-Man mouth, but without the circle around it, right? And then there's less than or equal to. There's greater than and greater than or equal to. Now, students always get them confused, like which one's less than, which one's greater than. Well, remember, when you read the word greater, you start at the left and move your way right, correct? Right? So when I read this line, I say using linear inequalities, blah, blah, blah. So I start at the left and work my way right. You read these symbols the same way. You start at the left and work your way right. So a symbol that has the pointy end on the left is less than, and a symbol that has the mouth on the left is a greater than. Just a little tidbit. Okay. Now, there are several properties of inequalities that you have to know, and they're not actually that hard. The first one you already know because it's just like equations, namely that in an inequality, any of the symbols, any of them, by the way, they're showing the less than one, but it'll work for any of the four. You can add something to both sides. And if you can add something, that also means you can subtract as well. So note, this is what this is saying is that we can add or subtract a quantity from both sides, right? That's basically all they're telling you in a nutshell, right? It's written in math speak, but that's what they're talking about. Okay. Hold on, let me change my. Sorry, there we go. Now you can see it a little bit better. Okay, now you're wondering, well, okay, that's not that big of a deal, right? And the answer is no, it's not a big deal at all. Okay, so let me go down here. We want to solve this inequality for x. So it's x minus 4 is, oopsie, I think it's less than or equal to 7. Cool. So according to that property in that blue box, we can add something to both sides. And what I would add, if I was you, I would add 4. And if you do it to the left-hand side, you've got to do it to the right-hand side because they're in this inequality, but they're in an inequality in a very particular way. So you don't want to rock the boat any more than necessary, if you will. So that's going to give you x on the left side, less than or equal to 11. There you go. There's your answer. Not hard, I know, but that's just because I'm setting you up here. I'm doing some easy problems. All right, now, it says to write it in inequality, graphing, and interval notation. Cool. Well, we got the inequality notation done. I'll even write it right here. This is inequality notation. It's the one you're most familiar with probably for inequalities. It's where you have one of those 4 symbols in there. But we also need graphing and we need interval notation. I'm actually going to do them in that order, and I'm going to make a little table here just so I can have room for my graph. Okay, so on the graph, you want a number line and you want to shade, well, you know what, let me go grab a number line. Hold on. There we go. Okay, so what I did was I made a number line and then I put tick marks on it. You don't have to label every tick mark under the sun, honestly. To be honest with you, when I'm doing this in class, I generally just label the number that I'm interested in, which in this case is 11. Anyway, so you put the dot at 11. Now you can put an actual dot there because you actually get to be 11, right? It says x is less than or equal to 11, so you got to put a closed dot there. And then what you do is you want to shade either to the left or the right. This case, because x is less than, right? X is smaller because the pointy end's at the x, right? So the big end is at the 11. So 11's big, x is small. So I want to shade all the numbers that are less than 11, all the numbers that are smaller than 11. So I shaded everything to the left over there. Cool. Now this helps you actually with your interval notation, believe it or not. hold on, I want to make this a little bit smaller just so it can fit beautifully. Okay. Now, how in the world does this help? Well, interval notation is kind of a slippery sucker. Interval notation is very important for mathematical purposes. It's how we write things in higher level classes. I have my caps lock on. Interval notation. Right, so it's kind of a big deal. So let's make some notes about it right now. How interval notation works. It goes left, comma, right. Or if you like, you could say the lower bound, not board, bound, and then the upper bound. So you're going to look left to right. Right? Now I'll put those in up here. So lower bound, comma, upper bound. Let me just put this lower bound, which is the left, upper bound, which is the right. Okay. Then you're going to have either brackets or parentheses, and it depends on whether you have actually got a closed dot or not. So let me put it that way. So it's lower bound, comma, upper bound, parentheses, or sorry, let me put it this way, bracket if brackets, not braces, those are bad. Hold on. Brackets if the numbers are reached. You actually get to them. You are, I mean, it's actually a shaded closed dot, right? So if you get a closed dot, then that, there we go. You get a closed dot, then you get to use a bracket. Otherwise, use parentheses for open dots or infinity. Much like Buzz Lightyear would say, to infinity and beyond, right? Okay, so that's the long and the short of it. Those are the notes on what interval notation is. And you know what? I'm going to put them over here. That way I've got more room. Okay, so interval notation notes. Write them down. Right, so interval notation goes left bound, comma, right bound, period. Right, that's just how it is. Interval notation uses brackets if you get to use a closed dot. Otherwise, it uses parentheses. Parentheses honestly gets used more often. Okay, so what am I talking about? Okay, so if you look at what we shaded here on the number line, you want to think about what's the left-hand edge of what we shaded and what's the right-hand edge of what we shaded. That'll be your interval notation. Well, let me make this smaller so you can see. There. Okay, so I think the right-hand part is easier to see. So if you think left, comma, right, if you look at where it ends on the right-hand side, where does the shading end? It ends at 11. Do you actually get to be 11, right? Does it have a closed dot? Well, yeah, sure it does, right? It's got a closed dot. So that means that it gets to have a bracket. Like that. Because you actually get to 11, put a closed dot there, bracket. On the left-hand side, it never ends. Now, I can't do this with the computer program that I use, but there's actually an arrow there. It keeps going and going and going and going, which means where does it end? It doesn't end at negative 15. It doesn't end at negative 20. It ends at negative infinity because it just goes and goes and goes forever. Like you would keep shading. You just keep going off your paper and keep going forever shading. So that means that you get a parentheses because infinity gets parentheses. The only thing that ever gets a bracket is something that actually gets a closed dot. Everything else gets parentheses. So this is the problem we're looking at. Closed dot on the right, parentheses on the left. That's interval notation. Right? It's a very important skill to have because in later in our class, but also in upper level classes, that's just how they write things. They don't write them with this inequality notation. They just write everything like that, period. It's all over calculus. So therefore, it's a skill that you guys get to learn in algebra class, because algebra basically is the servant of calculus. That's kind of its whole reason for being. Well, not all of its reason for being, but a lot of it. Okay? All right, done with that one. We're ready for the next one. Let me change this to 0, 0, just so we can get a little better spacing here. All right, now we could add and subtract, no trouble, right? But multiplying and dividing is kind of a different business, so let's look at it. If you're multiplying or dividing by a positive number, multiply or divide by a positive number with no changes, right? Just like you normally would. But warning, if we multiply or divide by a negative number, the inequality must be reversed. Okay, there's a little warning to ourselves. It's so important a warning that I'm going to put it in bright yellow so we can see it. Must be reversed. Period. That's just how those are. Okay, so positive number doesn't change anything. Negative number means big trouble. You've got to flip the sign. So let's look at this one, shall we? So I have it as negative 4x is less than 16. Okay, so I'm going to have to solve this for x. No trouble. She said, all right, negative 4x less than 16. You're going to divide, right? Divide by negative 4. And if you do it to the left, you got to do it to the right. This is not a hard problem, I know, but that's because I'm just trying to get you to understand the basics. Now look here. You divided by a negative number. Whenever you do that, you have to switch your sign. It was a less than symbol, had the pointy end on the left. Now it's a greater than symbol because it's got the mouth on the left. So x is greater than negative 4. That's inequality notation. We're only part way through. We got to graph it and do interval notation. Poof. All right, so there's a number line. And I shaded negative 4 over here, and I've got a shade to the right because I want greater than. Now, the only problem with this is that I don't want this dot over here. That came from the 11. That's totally wrong, right? Because I had 11 up here on this one. I changed it to red because I thought that'd be easier to see. Okay, so I need a dot over here at negative 4, but the deal is that I can't actually equal that dot, right? I don't get to put a closed dot like I did on the last one. So hold tight, let me change that. There, I tried a different way of bringing it in, so see if that helps. So there's negative 4 right there, and then you shade to the right. I kind of like the other picture better. Hold on. There we go. So there's the negative 4, gets an open circle. See that open dot there? Shade to the right. Now what would our interval notation be? Well, remember, interval notation goes left to right. So if you look at the red shaded area, what's the far left-hand edge? It's negative 4, right? Because you get up to negative 4, but you don't actually get to be negative 4, which is why negative 4 deserves a parentheses. You don't get a closed dot. Brackets only come with closed dots. Speaking of which, look at the right-hand side. So it looks sort of like it stops at 15, but au contraire, it doesn't. It keeps going and going and going and going forever. That's just a fluke of this program. And if it goes forever, the symbol for forever is positive infinity. Okay, but it doesn't deserve a bracket, right? That's no good. It deserves parentheses because parentheses always go with infinity. Again, the only thing that gets closed dots is, or excuse me, the only thing that gets brackets is closed dots. All right, so there's our interval notation for that one. I'll leave that in. Okay, we've learned a whole bunch of stuff. The basics of inequalities, the 4 different inequalities, the basics of interval notation, and graphing an inequality on the number line. I'll meet you back here for more stuff on inequalities, such as the linear inequality in one variable and solving for when there's x in there.